Hello, everyone, and thank you for joining us for today's webinar, Redefining 5G millimeter wave semiconductor test. I'm John Szymanczyk, and I'll be your host today. I was a test engineer for many years, and now I'm the Director of Marketing at Marvin Test Solutions. Jim Frame, our Director of Sales, and Victor Fernandez, our European Sales Manager, both with decades of semiconductor experience, will also be on our panel today. As we know, 5G test in the sub 6 gigahertz range is significantly less complicated than that for millimeter wave devices. Whether you're dealing with instrumentation, interconnects, cabling, and all the other parts that are involved in the test system. But as we move into the millimeter wave test arena, many aspects of tests become more complicated, and this impacts almost every area of test systems, including calibration. Vector network analyzers are a key part of millimeter wave system level measurement accuracy and repeatability. And this is why we've partnered with Keysight Technologies and offered these devices in the Genesis Semi systems. And we leverage this measurement science in the Genesis millimeter wave solutions, both for millimeter wave test as well as a number of other aspects. Transitioning this measurement science from the popular PNAX to PXIe-based instrumentation results in a compact instrument that provides exceptional performance, flexibility, and the speed needed when we transition from the laboratory to the semiconductor production test environment. Now we'll take a look at the technology involved. Beamforming is a key technology in millimeter wave communication systems, which enables reliable and efficient communications in the millimeter wave band by transmitting focused signal using phased array antennas. And we have the diagram here that you can view for reference. If you look at the antenna module, it's comprised of many built-in beamformer ICs and antenna elements, and that's the area that we're going to be focusing on. The beamforming IC is a multi-port module that integrates transmitter and receiver blocks into an RF front end, which is then connected to a number of antennas depending on the application and what the customer is trying to achieve. With the new modular approach, each front-end module includes a transmitter power amp, the receiver low noise amplifier, and possibly switching depending on what the customer is involved in, all packaged together in a single module. The module has many ports, multiple frequency bands, and more functionality. So there are many parameters to test and that we need to be concerned with. We have two measurement examples illustrated here. One's a high power vector network analysis, and the other is a low noise power ratio measurement. Both measurements require direct receiver access configuration, and the PXI instrumentation is a good fit for both of these applications. Distortion tests are particularly important for space-based applications because the power amps are operated in compression in almost every case. For noise power ratio measurements, it's supported with the spectrum analysis class of the PXI VCAs. In the transmit mode, the signal from the transceiver passes to the power amp, switch, and then to the antenna. And the receiver mode, the signal is from the antenna, passes through the switch to the low noise amplifier, and then to the receiver section of the module. To ensure reliable 5G communications, the performance of this component has to be tested under linear and nonlinear conditions across the entire workflow design from verification all the way to manufacturing. Testing includes network analysis along with modulation distortion analysis such as error vector magnitude or adjacent channel power. So multiple instruments typically are needed to complete all the measurements required. And again, some of these measurements, and we'll see this moving forward, aren't necessarily required in the production environment. And again, it's up to the customer and exactly what they're trying to achieve through the various test methodologies. The key challenge for our customers is how they can efficiently transition to the manufacturing phase without sacrificing measurement accuracy, all while increasing throughput. And as one of my colleagues says, related to semiconductor tests, speed is king. And we're going to see how that plays out as we move a little bit further in the presentation. So now we'll move to the system level and discuss the challenges test engineers face when transitioning to millimeter wave production test. Basic interconnects and cabling are almost an afterthought when you're dealing with many low frequency applications. But with millimeter wave frequency, there are many factors that contribute to measurement error, and each must be carefully considered and addressed. For example, as we consider the measurement path from the VNA instrumentation to the device under test, we find multiple interconnect cables, the associated connectors, blind made interfaces, and the impact from the load board itself. In the production environment, each of these contributes to the test system error budget, whether it's insertion loss, signal reflections, repeatability, the blind made interfaces, or the cable performance. And oftentimes, if you measure performance from system to system, simple things when you're dealing with higher frequencies, such as cable routing and having consistent bend radius throughout the various system, plays into it and makes a big difference because it can impact the overall system performance. So that's where manufacturability comes into this. It's just not an engineering exercise. Now, before we move into the test system details, I'd like to take a quick look at the type of performance data that's expected from users when testing and characterizing millimeter wave semiconductor devices. The performance tests shown are really no surprise when dealing with these types of devices, and they include insertion and return loss, variable gain amplifier performance across the entire operating range of concern, and power gain in phase performance. In some instances, manufacturers are also concerned with characterizing the noise figure to understand noise output of the receiver and the adjacent power ratio to understand power contained in a specified channel relative to the total carrier power. We can then translate the performance requirements into the types of measurements and control signals that must be supplied by the system, effectively a test requirements document. As discussed earlier, the Keysight VNAs are used to perform S-parameter measurements as well as the gain and phase measurements. Basic communications to the device under test typically occur using the SPI bus or an I2C interface and are performed using the dynamic digital I/O card with basic register reads and writes. The digital interface is also capable of performing contact tests prior to applying power to the semiconductor device. And this is done by leveraging the per pin parametric measurement unit functionality on the dynamic digital cards. And it's a very essential part of our test process before we actually apply power to the device under test. Now let's take a quick look at automating, why automating these measurements is critical for the production environment. While the use of laboratory instrumentation and manual setup will certainly yield acceptable results, and especially when we're dealing with the instrumentation that we've already referenced, but we must be aware of issues associated with this, including long-term repeatability and the potential for damage when handling cables that are removed and reconnected repeatedly. So it's definitely a concern in the production environment. Additionally, test speed and footprint will be unacceptable with a manual configuration for most production environments. So not only is speed king, we also need to be concerned with footprint in having a compact test system. So moving into the automated test arena, MTS has designed and delivered millimeter wave semiconductor device test solutions that leverage an open architecture design which simplifies expansion and instrumentation updates, with the base configuration being able to support up to 20 independent VNA ports. System level measurement performance up to 44 gigahertz has been validated in multiple production environments, with independent non-multiplex multi-site testing performance up to 53 gigahertz being possible simply by selecting different VNAs from the Keysight solution set. Careful selection of cabling interconnects in blind made interfaces ensures repeatable test performance to the device under test. And we'll see in just a minute how test times are by far the fastest in the industry with the Genesis Semi system. And we're not just talking a couple seconds, we're referencing orders of magnitude better. These solutions are also support the most common probers and handlers, allowing the reuse of existing assets on the test floor. Now, test system flexibility in being able to easily update instrumentation and capabilities is a key concern expressed by many in the semiconductor test community, and it's just not semiconductor, it's across the entire ATE infrastructure as well. The PXI platform, and for those of you not familiar, or PXI extensions for instrumentation, is utilized because the modular instrumentation architecture delivers a PC-based solution that incorporates high-performance instrumentation with the benefits of the open industry standard. And as I mentioned earlier, even transitioning from laboratory-grade instruments to the PXI VNAs, it utilizes the same measurement science. So we're taking advantage of that same technology. There are many advantages over traditional proprietary designs, including scalability, reduced footprint, power requirements, and the least of which we can't forget is obsolescence management. Oftentimes that's not taken into account when the systems are initially purchased, but 3, 5, and so forth years down the road, it can definitely become an issue. Utilizing our modular instrumentation also allows the system capabilities to be expanded or upgraded to higher frequencies with minimal effort, as we've already mentioned. And the highly integrated nature of the PXI platform also delivers advantages in system throughput, which we'll see, bandwidth, synchronization, all resulting in test times significantly faster than other solutions. Now we're just going to take a few minutes to step through the instrumentation that's involved in the Genesis Semi mmWave solutions. As I've already discussed, the Keysight VNA instrumentation is the heart of the RF measurement subsystem, delivering exceptional measurement performance and repeatability. The source measure units have been incorporated to deliver precise multi-channel device under test power with the ability to force voltage and accurately measure, or in some cases limit, current being an essential requirement for these tests. Manufacturers need to understand current draw during different operational site conditions, including reset, sleep, idle, and while operating devices at the maximum design limits. The multi-channel SMU is an ideal solution for this type of application because a single instrument can deliver isolated, independent operation for up to 4 independent domains. The digital interfaces are primarily used to communicate and control the semiconductor devices, typically with either a SPI bus or I2C interface. The dynamic digital card is ideal for this type of application. It can be programmed to communicate with either of these as well as other interfaces. The per pin parametric measurement unit, or PMU, and it's essentially a SMU on a pin, is typically used to verify connectivity prior to applying power to the device to minimize the potential for damage, ensuring that all the connections are in place in all the various power and return lines are making good contact. And the low board and daughter board IDs are also verified using this digital interfaces as well. Now, sometimes the critical nature that the chassis plays can be overlooked, especially when we're talking about exciting stuff like VNA measurements at 44 gigahertz. But the chassis is definitely a critical link in the system, especially from the standpoint of heat and cooling. Scaling the Genesis Semi up to 20 VNA channels means incorporating 5 total VNA instruments, additional SMUs as required, and possibly more digital interfaces, all of which place additional power and, just as importantly, cooling demands on the overall system. The smart chassis delivers the high power and airflow needed for these types of apps and incorporates smart functionality to monitor the voltage and temperature while in use. As with any automated test system, software also plays a critical role. The AT Easy Test Executive and Development Studio provides the interface to all instrumentation, and its easy to use text-based development environment simplifies and speeds software development activities. So the text-based type interface is real similar to the Visual Basic in the types of programming language that we used while in school. The test executive, or as some people refer to it as the test sequencer, provides a well-defined structure for test execution, debugging, and also for generating test documentation, which is critical in just about every application we deal with. It's also the most cybersecure integrated test executive and development environment available, and it's already been adopted and in use by many military and aerospace customers. A suite of semiconductor utilities is also provided, and we'll see a little bit more about that as we move forward. So system level calibration's another critical aspect of any automated test system, and the mmWave test is certainly no exception to this. The measurement path includes many sources of error that result from our interconnects, the cabling, blind made interfaces, and these must all be quantified to accurately isolate and measure the performance of the device under test. Once the measurement path is characterized, the linear error can be removed from the test system to isolate the device under test itself. The most accurate approach, and that which we have adopted in the Genesis Semi systems, involves a multi-step process to isolate the device under test. First, we calibrate the RF path up to the device under test using traditional methods. Test coupons are then used to characterize the device under test forward path from the connector to the device and then back again. From this, the touch tone data is generated, which is an ASCII file that essentially consists of frequency values and the pairs of values for the magnitude and phase of each of the S parameters for the various frequencies that we're testing to. Then this is all combined to provide the overall calibration solution and to accurately and repeatedly, just as importantly, characterize the signal path to and from the device under test. So taking this approach, we can very accurately characterize that path, and over time we can rerun our calibrations and ensure that we're not seeing any kind of drift. Now we'll just take a look briefly at, from a test system architecture. In the industry, we're familiar with seeing the big iron testers, the commercial proprietary testers. So what's the real difference between that and looking at an open architecture approach such as the Genesis Semi? Well, first of all, cost is a big consideration. The second is support structure. It tends to be very rigid when you're dealing with proprietary systems as opposed to open systems where the support tools are readily available, whether it's for software or hardware. And then from the standpoint of customization, many larger proprietary systems, it's difficult to customize and it takes a lot of interaction and oftentimes expense with the manufacturer versus a open architecture approach that's modular in nature. And we've already talked about expanding, for example, VNA channels. We simply plug in additional cards and we update our software accordingly. And then obsolescence management's a major concern with any test system. And there's no question that it comes into play with the big iron testers versus the proprietary or the open architecture system that is supported by many, many vendors out there, providing a large and diverse supply base. So it really gives us the opportunity to qualify additional instrumentation as needed, as well as add additional capabilities as we may need as well. Now, we talked about test time a little bit, and I think this slide really drives it home. So if we take a look at a couple test configurations that we've run. For example, let's just start off with 6 ports, single site, and take a look at what our test time is from mmWave device, 13.3 seconds. For sake of contrast, let's jump down to competitor B. It's a big iron tester, only 4 ports, a single site. Take a look at the test time, 132 seconds. Again, going back to speed is king, we're looking at an order of magnitude faster with the MTS Genesis systems, the TS900E-5G. Now let's even bump it up. Let's look at 12 ports, dual site, 14.4 seconds. Nobody else in the industry can touch these levels of performance in these test times. And by the way, these have been validated at customer sites in production environments. So this isn't just what we're doing in our lab in the facility. What about other performance considerations that you may be concerned about? Well, vector correlated measurements are key when we're dealing with mmWave and RF measurements. Having gap-free measurements through the entire range is also critical, and none of the competitive devices have that. If you look at the open architecture aspects, the ability to expand ports is needed. Just because we need 4 points today doesn't mean that next device that's rolling off from design into validation doesn't require 8 or 20. So it really gives us the ability to quickly and easily expand and modify the test system. What about compatible measurement science with the PNAX? Many customers are using the PNAX in the lab, and it's nice when you transition to a production environment to have like measurement science. So if you see something that's not quite making sense from one system to the other, at least we know we have the consistency of that RF measurement device that we're dealing with. When we're installing, just being able to use 120 volts or 220 volts versus a 3-phase implementation makes a big difference. Same as far as cooling. If you need to run water cooling, that takes time, it takes facilities, as opposed to just having the standard air cooling. And what about install time? And we've validated this at multiple sites. The 1 hour is being it provides about 30 minutes longer than we really need, both to install and run self-test. A typical installation, less than an hour, we're fully up and running, we've run self-test, and essentially it's ready for the customer to use. So again, very, very key performance considerations to think about as you're looking to transition to a production environment for mmWave tests. Now we're going to look at a way to extend capabilities for big iron testers. So the MTEC, which stands for Marvin Test Expansion Kit, it's a PXI-based test solution that offers modern instrumentation to extend the life and capabilities of these legacy semiconductor ATE systems. It can be readily integrated with legacy ATE platforms, providing improvements in advanced digital capabilities, analog, and of course, what we're concerned about today, RF test capabilities. It's a flexible, scalable solution that can be specifically configured to address a range of test needs, both for our packaged and wafer test applications. It's designed to support both engineering and high volume installations, and it's an ideal solution for extending the life cycle of these legacy ATE systems. This is a great image of what it looks like in use at a customer site. You can see, looking at the block diagram, it's pretty straightforward. So we have the MTEC system itself, which interfaces to the computer via an interface. And then we have the cabled interface going to the load board for the instrumentation, digital I/O, whatever it may be. So you can see it's a very elegant, clean solution, and allows you to continue to extend the life of the capital investment that you may have already made and you're not looking to necessarily replace today. A very clean, slick solution. Now, real quickly, we'll just look at the software tools again. ATEZ Test Executive, the key thing here, it's an integrated development environment with Test Executive. So you have all the test sequencing built in and tied together. It allows you to define and process or processes for editing, running, and debugging. And we also provide tools for semiconductor test as well. Comprehensive software tools, including IV curves and SMU plots, as well as file translations for a lot of the standard popular formats that are out there. So to summarize this before we go into the question and answer section, the Genesis Semi system is definitely the highest throughput production test solution available today. Some of the key things: the open architecture versus closed proprietary systems, the VNA RF performance, whether it's vector correlated measurements, the gap-free measurements all the way out to 44 gigahertz, or if we swap our VNA instrument to 53 gigahertz, the ability to have that compatibility with what we've done in the lab with the PNAX instrumentation, with the instrumentation that's actually in our production test set, the installation piece of it, having simplified installation in quick turns on that, both from the standpoint of being air-cooled and utilizing single-phase power, the scalable expansion and in the advanced functionality that we can provide by modifying the instrumentation set that we're using, being compatible with the standard wafers and wafer probers and device handlers that are already out there on the production floor, and then the comprehensive software environment and tools that we've already looked at. So what we're going to do now is move to the question and answer section. And what I will do is I'm going to unmute two of our other panelists, one being Jim Frayne and one being Victor Fernandez. And as I mentioned earlier, both these gentlemen have decades of semiconductor test experience. And what we'll do now is open the floor up to test. And I'm going to turn this over to Jim. Jim, I believe you can hear me, correct?
I can hear you, John.
Very good. Okay, so Jim, why don't you take us through some of the question and answers that we've received? And
I think I was going to ask if Victor had them. I have them in front of me, I think. Victor, do you have them there as well?
Yeah. You can hear me?
Yes, we can, Victor.
Yeah, I have a couple of questions that we got. Are there special features required for production testing of 5G and mmWave devices?
Yeah, good question. The question is on fixturing. And yes, for all semiconductor devices to test equipment, you require fixturing for either for both production in probe, wafer probe, and in final test. And we provide a fixture that comes with the system for doing self-test and allows customers to do prototyping with basically wiring up a device quickly and easily to start doing test development.
Great, thanks, Jim. Victor, did you have additional questions?
Yeah, two more.
Okay.
Okay, it's one. What does the user of the system need to do to get features for their products?
If you're looking to get fixtures for the TS900E-5G, you contact Marvin Test. Our team includes folks who have been doing this for 30 years, specific fixture development, more specifically mmWave, so high frequency fixture development, which brings up some special challenges, and finally, fixtures that allow you to connect directly to handlers and connect directly to probers. So we'll help you with that effort.
Hey, Jim, as well, could you maybe comment about how MTS would be the single point of contact as far as all the various aspects of the test system, so you're not dealing with 3 or 4 different manufacturers?
Yeah, good question, John. We since we partner with Keysight, and people on this call and all our customers have a lot of experience with Keysight. and they talk to them on a daily basis. They like to know, so if we have a problem with Keysight, with Marvin Test, with the manipulator, whatever it is, who do we call? There's quite a few components. You call Marvin Test again. We are the single point of contact. We'll get in touch with everybody. We will bring in Keysight and whoever else is needed, and then our own experts will help. So it is Marvin Test system and Marvin Test responsibility to support the customers.
Very good. Thanks, Jim. And Victor, do we have any other questions?
No, that's it. That's no more questions.
Well, good questions. Thanks, Victor. Thanks, John.
Very good.
Just, yes, we got another questions. One question about, can you support those the systems worldwide?
Yeah, we have our systems now are installed. Marvin Test equipment is installed around the world. The basis of these systems, the hardware, the cards, the chassis, we've been installing around the world for the last 20 plus years, and so we have support around the world as well. And but we see major support and installations going in North America, in Asia, and in Europe.
Okay. We have another question. Don't we also want to say that there is third parties who have developed features for the 5G testers?
Yeah, well, we have, obvious one is Keysight. They lead the world in millimeter wave development, Victor, and as far as the solutions and tools, all Pixie-based, by the way, and through their VNAs, which really is an extension of their PNAX instrument, which is kind of a world leader in millimeter wave tests. And so these instruments now are on a Pixie card that can install and that installs on our machine, gives us the same capability or very close to it, what people have been using in the lab the last couple of years. So yes, through Keysight and others, we have the ability to support many different applications.
Okay, very, very good. Jim, any additional comments you'd like to make about the system before we wrap up today?
No, it's a really pretty system, John. Thank you.
Oh, that's good, Jim. That always helps. Okay, well, I would like to thank everyone for attending today. If there's no other questions, we'll go ahead and put the wraps on today's call. I would like to say I hope everyone's staying safe and healthy. We know we still have challenges dealing with COVID, so I'd like you to wish the best to everyone and to your families. Thank you for attending today. We hope you have a great rest of your day, and feel free to give us a call. In Europe, obviously, it's Victor is our key contact. Feel free to reach out to Victor, as well as Jim Frayne or anyone else within the company, including myself, and would be happy to engage in the conversations and answer your questions. So again, thank you very much. Have a great day, and we look forward to seeing you in our next webinar. Thank you.
Thank you. Bye. Thank you.